Alright guys, welcome back to another LeetCode tutorial. So today's problem is called Remove Linked List Elements, and it's a part of day 20 of the July challenge. So our problem description is remove all elements from a linked list of integers that have a specific value. So if you look at our input here, our value is 6, and we're given this linked list, and as you can see in the output, all of the nodes with the given value are gone. So I think the problem description is pretty straightforward. But this problem is a little bit tricky because there's some weird edge cases that we have to deal with. And for that, I want to turn to the whiteboard so I can show you guys how we're going to deal with those specific edge cases. Alright guys, so as I said before, we will have multiple cases here. So the first case is just the simplest one. We are given some empty list, or aka the head they're giving us is null. In which case we would just return null. So the first case isn't too exciting. So we have the following linked list with a target of 1, such that the head node is the one we want to get rid of. So the question is, how are we going to do this? Well, it's actually a lot simpler than you think. So what we need to do is we need to initialize a dummy head, essentially. And this head is just going to help us in the case where the node that we want to delete is at the front, right? It'll just make it very simple. And this is what I mean. So if you look here, we have our dummy node, and then the rest of the list just stays the same. And I also want to introduce a current pointer. So current and dummy will start off at the same node. And essentially this is really all we have to do. All we really have to do is just check and see if current.next has our target value. And as you can see, if current is 0 and the next value is 1, current.next does equal the target. So in that case, we would just say that current.next equals current.next.next. So as you guys can see here, it's a little bit more explicitly stated, but what I want to do is I want to say current.next equals current.next.next right here. Essentially, what we've done here is we've broken the link from current and current.next, and we've attached that link to current.next.next. So when we do that, when we actually break that link, you can just imagine that the old next is just gone. And essentially, current.next.next is now current.next. So as you guys can see, just by introducing this dummy node, we can delete our head while keeping the rest of our list intact. So for the case where the target is at the head, we're good. So we are now at case 3, where we have multiple nodes that have our specific target back to back. So for this case, this is what it looks like. So let's say this is our list. We have 10, 3, 3, 5, and let's say our target value is 3. So for every node with a value of 3, let's delete it. Again, first things first, we want to introduce our dummy node. Alright, so we now have our dummy node, and as always, dummy is going to start off at the front of the list, as well as a current pointer. So, as always, first thing we got to do is current.next equal to the target. The answer is, no it's not. Current.next is 10, so we move on. Alright, so we've advanced current 1 spot, and we ask ourselves again, is current.next equal to the target? And we see, yes it is, so like we did before, we're going to set current.next equal to current.next.next. And in order to do that, again, we break this link right here between current and current.next, and instead, what we're going to do is we attach that link from current to current.next.next. And now, since we have reassigned that link, you can just pretend like the old next is gone, and our new current.next is 3. So, in this case, you might say, okay, well, now that we deleted current.next, advance current to the next node. But the catch is that if we do that, we're not actually going to end up deleting 3. Think about it like this. As you can see, if you advance current with our with the algorithm that we have now, we're checking to see if current.next is equal to the target. not if current equals the target. So for that reason, whenever we delete a specific node that has our target, we want to keep current the same. So now that we've maintained current in the same spot, again we ask ourselves, is current.next equal to the target? It is, so current.next equals current.next.next. So that link is broken and we're just left with 10 and 5, and we would just return this list right here as our final answer. So as you guys can see here, our list is 225. We have a target of 2. So essentially the list that we want to return is just 5. And so the answer is, how are we going to do that? Well, like always, we want to introduce our dummy head. So we introduce our dummy head, and of course we also have to introduce our current pointer, right? And so now that we have our current and our dummy, we're just going to do what we've been doing all along. So we check, is current.next, does that have our target? We see it does, so we're going to assign current.next as current.next.next. So we break this link, act like this node is just gone, and we attach a link from current to current.next.next. And now, like we did before, right, don't advance current just yet, because if you advance current, we're going to forget all about this node right here, and it won't be deleted. So keep current the same. So once we keep current the same, we ask ourselves, does current.next have our target? We see it does. So, like before, detach this link here, and reattach the link from current to current.next.next. Once you do that, pretend like this node was never there, and so the list we would return would just be the list of 5, and that's it. And for case 5 here, let's say that the tail node has the target. This case isn't too bad, and I'll show you guys how we're going to address it. So now that the target is at the tail node, we're not going to really do anything different, guys. Still, we introduce our dummy head, and of course we still introduce our current pointer. And so we would ask ourselves, does current.next have our target? And as you guys can clearly see, that check is not going to get set off until current is right here, right? So when current is in that position, current.next does have our target value, so all we would really do is the same thing. Current.next equals current.next.next. So essentially, like, 3's next would just be null, really. So we would break this link here, and essentially current.next would just be null. And, when you do that, the 3 is gone, and we're still good. So we would return the list of 1 and 2, and we're good. Alright guys, so now that we know how to solve the problem, I want to jump straight into the code. So as we said before, we first just want to check and see if the list that they're giving us is empty or not. So if the head is null, we would just return the head. Otherwise, we have a little bit more work to do. So we're going to introduce a new variable called dummy head and a current pointer. So dummy head is just going to be equivalent to a new list node, I should say. And we can just pass in any arbitrary value. And we want to say dummy head.next equals head. And the reason we're doing this is because we actually want to have a way of traversing the list they're giving us. And so we also need some node that is going to traverse the entire list. So we're going to introduce another node called current and set that equal to dummy head. And now that dummy head.next is equal to the head they're giving us, we can traverse the entire list with no issues. So while we still have nodes to look at, aka while current.next is not null, we first want to see if the node we're at has the value. So if current, So if current.value equals the value we're searching for, double equals right there, then we would just say, actually before I forget, this should be current.next.value. There we go. So if the next node in the list has the value we're searching for, I should say we would want to say current.next equals current dot next. So yeah, there we go. So current, yep, that looks good. And otherwise, so if the current node that we're at does not have the value that we're searching for, we would just want to advance current pretty much. So current equals current.next. And that's really it. So yeah, that looks good to me. And finally, we would just return dummy head.next. And we should be good. So let's just run it to make sure we are okay. And it looks okay so far. Let's submit it. And we're good. So yeah guys, that's how you solve remove linked list elements. I hope the video is helpful, and I'll catch you in the next one.